This video will cover sketching the antiderivative of a function. Given the graph of the derivative f prime of x and the initial value f of 0 is equal to 50, sketch the graph of the antiderivative. So here's the graph of the derivative, and our goal is to graph or to sketch the antiderivative of this function. Notice that f prime of x is piecewise continuous on 0 to 40. There's a jump at x equals 30 and also at x equals 40. Okay, so the solution is f of x is 0 to x, the integral from 0 to x, f prime of t dt. And the critical points of f of x occur at x equals 20 and x equals 30. Since f prime of x is equal to small f prime of x is equal to 0, that's the definition of critical point, is when a derivative is 0. So where the derivative cuts through the x-axis, we will have a maximum or minimum for capital F of x. So that happens at x equals 20 and at x equals 30. The inflection points of the function occur at x equals 10 and x equals 25. That's where the derivative f prime of x has a maximum or minimum. That would be these points here at x equals 10 and at x equals 25. When a derivative is maximum or minimum, we're going to have an inflection point for the antiderivative. So now let's apply the fundamental theorem of calculus. We know that f of 0 is 50, and f of 10 is going to be f of 0 plus integral from 0 to 10 f prime of x dx. That's going to be 50 plus 1/2 times the base times the height. So the integral from 0 to 10 is just the area of this triangle. 1/2 the base, which is 10, and the height is also 10. That gives us 50. So 50 plus 50, that is 100. F of 20 is going to be f of 10 plus integral from 10 to 20 f prime of x dx. That's going to be 100 from before, from our calculation, plus, and the integral from 10 to 20 is also going to be a triangle 1/2 the base times the height. So 1/2 of 10 times 10, that's adding another 50. So 100 plus 50, that's 150. Now let's look at f of 25. That's f of 20 plus the integral from 20 to 25 f prime of x dx. But notice that f prime of x dips below the x-axis from 20 to 25, which means that we have to subtract off the area. So that's going to be 150 minus 1/2 times the base of 5 times the height of 5. That's going to give us 137.5. That's capital F of 25. Now let's look at f of 30. That's going to be f of 25 plus integral from 25 to 30 f prime of x dx. That's going to be the previous value, 137.5. And from 25 to 30, the function is below the x-axis, so the area has to be subtracted. So that's going to be minus 1/2 times the base times the height. Half of the base is 5 from here to here, and the height is 5 as well. And now let's look at f of 40. F of 40 is going to be f of 30 plus integral from 30 to 40 f prime of x dx. We have 125 from before, and the integral from 30 to 40 is just going to be the area of a rectangle. So that's just 40 minus 30, that's the base is 10, and the height is 5. 10 times 5 is 50, so that's going to be 125 plus 50, that's 175. So let's now look at the graph of the antiderivative. We start off with f of 0 is equal to 50, and notice that the inflection points are at x equals 10 and x equals 30. These correspond to, at x equals 10, we have a maximum for the derivative, and at x equals 25, we will have a minimum for derivative, and those will become inflection points for the antiderivative. The maximum and the minimum for the antiderivative correspond to where the derivative graph cuts through the x-axis. So that's at x equals 20 and also at x equals 30. That's at this point and this point. Notice this portion of the graph is a straight line because the derivative was a horizontal function. So the area is increasing at a constant rate. And that's why we have a straight line segment from 30 to 40. All right, thanks.